Welcome to HFWorks video tutorial series. Today, I'll show you quickly how to model a dual band 5G waveguide filter in HFWorks and SolidWorks. Again, the HFWorks is an add-in to SolidWorks, so you don't need to import or export. So right click, add a study as parameter, okay, and as frequency, you want a frequency sweep. When you go, this is 5G, so you're going to go from 27 to 29 gigahertz, and 100 frequency points. For the meshing, just take the default adapter, say OK, and your feature manager tree is created. Start applying material. So the housing is just copper, so my favorite material, copper. And I have this. This is the cavity filter, which is the air region. I go to my favorite material again, and then this part of different bodies. So these are two are the inner or central conductor of the coaxial cables. So those are, I can apply material, and so the cable, and they can choose Teflon, and this, actually these are copper, okay, and these two are the Teflon. Okay. After that, we simply, the only boundary condition I have to apply is the port boundary condition. So that is port 1, it's a coaxial waveguide, and then another port boundary condition, and that is port 2. The rest, meshing is adaptive, it's automatic, so you don't need to worry about it. So once you do that, after you run, let's quickly go and look at the results. So first set of results is the S11, S12. So as you expect, it's a dual band, so you have two passing bands. Okay. This is really the HFWorks results, again the measurement, so as you can see it's very close. You can also look at table results. The table results for each frequency, okay, you have these results available to you. Start from generate this matrix, renormalize it, Y and Z matrix, and port results. Okay, so, okay, and then you can look at the field data. So you can plot, fringe plot. If you want clipping, no clipping, let's do no clipping first. Okay, and then we can excite mode 1 or mode 2, and then if you want to look inside, you right click, clipping, you do section clipping, and then it's coming. So you want to put section only, I can move my section around, okay, say okay, and then actually I can animate versus sections. So this is automatically going to create different sections. There you go. So it's showing you how you can look at the field at different cut planes. Okay. You can look at the, if you want to look at the vector, you can look at also vector, no clipping. So this is your vector field, and again you can excite with, you can, this is 1 watt power, you can excite with whatever watt power at the input port. You can excite with mode 1 only, or port 1 only, or port 1 and port 2, and you can superimpose. You can say I put 200 watts here. There you go. I can again animate. Okay. So as you can see, you can very quickly create a study, run it, and visualize the results. If you want to look at the loss density, you could, at the end, create a report, generate a report. You can customize your report. Okay, I can put my company logo. Okay, I can put my name, company, date, and generate an HTML report. The report will have everything, all the pre and post processing and the simulation results, all in nice, concise report that you can access or share it on the web or with co-workers. So it's coming, the report, it's generating the report right now. There you go. Okay, 1 second. Okay, so this is your report. You can jump directly to different sections. Okay. If you want to make a quick change, you could simply copy this study, study 3, okay. And then once I have a new study, I can just go ahead and change whatever I want to change in that particular study. Or if you have many studies, I can just, before I go home in the evening, run all studies. That's it. Thank you very much for your attention. Thank you.